Let's look at a sample access control list that we can use for filtering on R1. Let's just go ahead and ping right now. Let's ping 2001:A:7 :7. So that's the interface on R7. We have successful connectivity. Let's go ahead and try telnet. Let's telnet to that same IP address. So we'll do this, and we'll say telnet. And it says password required but none set. So this confirms that we can successfully telnet to R7. But what I'd like to do now is I'd like to prevent telnet from happening. We won't even let the traffic get over to R7. So we can accomplish this on many different interfaces in the organization. Specifically, let's do it inbound on R3. So we go to R3. We're going to create an IPv6 access control list, IPv6 access list, and we're going to name this one deny who. We're going to deny R1, deny underscore R1 underscore, or deny telnet. Deny telnet from R1. Ooh, that's a long name. And that's it. So it's extended automatically, and it's named. That's the only options we have. And in this case, we're going to deny what? We're going to deny telnet traffic. So is that TCP, UDP? Great, it's TCP. And it's going to come from who? Specifically, it's coming from R1. Now, what interface on R1 is it coming from? If you recall how the ping process or the telnet process works, if you don't specify a source address, it is the exiting interface that is used as the source. So in this case, it's gigabit Ethernet 2/0 on R1. So we're going to deny 2001:A:13:1. And then we have to specify a prefix. Now this is where it can get a little tricky. Am I trying to deny a specific host here? Yes. So how many bits of the address do we want to match? I want to match all of the bits. It's this specific host. So if I want to match all of the bits, I say /28. If I want to match the first 64 bits, then I put 64. If I want to match the first 80 bits, then I say 80. But in this case, /28 is like saying host. Host 2001:AA:13:1. Similar to that. And then what's next? Well, where's it going to? What's the destination? In this case, it is R7. And it's R7 at 2001:A:7. /28 again. It's a specific host. And then what is it equal to? Equal to telnet. So telnet, as we can see, we can either specify telnet itself, or we can specify the number 23. So we'll specify telnet in this case. We'll hit enter. And then let's not forget to permit everything else. So permit IPv6 any. So in this case, do I have to explicitly permit the neighbor discovery, NA and NS messages? No, because they fall within this permit IPv6 any. All right, let's go back. Oh, let's apply to an interface. So interface, gigabit Ethernet 1/0, IPv6 traffic filter. I'm going to have to scroll back up now and get the name of that traffic filter. It's way too long for me to remember. There it is. Copy and paste that. And then we'll say inbound. So it's inbound on R3's gigabit 1/0 interface that we're doing the filtering. Show IPv6 access list. All right. Deny telnet from R1. Let's go ahead and try to ping, and we'll see what happens from R1. It's working. Let's go over to R3. We can see we have 17 matches on the permit. Nothing on the deny yet. So let's go back to R1 and let's generate a telnet session. Ooh, destination unreachable. Gateway or host down. Is it really? No, not at all. But if we go over to R3 and we look at our access list, one match right there. Denied. Let's do it again. Go back to R1. Generate a telnet. Go back to R3. Denied. We have two matches now. So remember, with IPv6, we have named, extended IPv6 access control lists. And let's not forget about the implicit deny all rule that we find at the very end of the access control list. But more importantly, don't forget about these implicit permit rules, because if you're denying in the access control list explicitly traffic for logging, then you are overriding the permits. So don't forget about those. Be mindful of those when setting up your IPv6 access control lists.